Now body is projected vertically up. Now when we say it is vertically up, it means that initial velocity must be taken as negative because finally the velocity will become zero. Because at the highest point the velocity final will be zero, and because the body is going vertically up, g must be taken as negative. Taking initial position as origin and the direction of motion, that is vertically up, as positive. Here we have minus g into acceleration is downward while motion is upward. So g will be taken as negative. If the body is projected with velocity u, the equations of uniformly accelerated motion for the vertical upward motion or for the ascending motion will become v is equal to u minus gt, s is equal to ut minus half gt square, and v square minus u square is 2gs, or it is v square is equal to u square minus 2gs. We have taken g as negative because the particle is projected vertically up. These equations can be used to solve most of the problems of the bodies projected vertically up. Now, in the three graphs again, the very first graph is the relation between s and t. It is depicting the graph between distance and time. We are finding distance is taken on the y-axis, whereas time is taken on x-axis. If we apply the equation of distance, s is equal to ut plus half gt square, from that we can get the value of s. Or 2gs is equal to v square minus u square, and from that we will get the value of v square or the value of s, and it is found to be u square over 2g. And if we use the equation v is equal to u plus gt, then from that equation we will get the value of t in terms of u, and that will become u over g. Now in the second graph, we are finding the graph between u and t. That is the positive value of u and the negative value of u. Then the line which is joining the y-axis and x-axis, it is inclined, so it is indicated by u over g or 2u over g. The third graph is indicating the relation of acceleration and time, and the separation of the two lines will be acceleration due to gravity. When the body is going up, g will be minus. When it is coming down, g will be positive. Now there are certain important points to be remembered. Like in the first case, the motion under gravity for a given body, mass, acceleration, and mechanical energy remains constant because all these equations are independent of mass, while speed, velocity, momentum, kinetic energy, and potential energy change. The another point is, which is very important, the motion is independent of the mass of the body. As in any equation of the motion, mass is not involved. This is why a heavy and a lighter body, when released from the same height, reach the ground simultaneously and with the same velocity. Time can be estimated by function 2h by g under root. This is estimated from equation s is equal to ut plus half gt square, assuming that initial velocity is 0. The second second equation, the velocity is estimated as root 2gh, and this equation is obtained from v square minus u square is equal to 2gh, where u is taken as 0 and v will be equal to under root 2gh. However, momentum, kinetic energy or potential energy depend on the mass of the body. That is, they are all depending upon the masses. So in case of the motion under gravity, the speed with which the body is projected up is equal to the speed with which it comes back to the point of projection. That is, the time of ascent must be equal to time of descent. Now there is certain example, a ball is thrown vertically upward. The moment we find that it is upward, g must be negative, and u is decreasing, and finally v will become 0. From a bridge with an initial velocity of 4.9 meters per second, it strikes the water after 2 seconds. If acceleration due to gravity is 9.8 meters per second square, what is the height of the bridge and with what velocity does the ball strike the water? Now to solve this question, we will take the point of projection as origin and the downward direction as positive. So first equation we use, s is equal to ut plus half at square. We have h is equal to minus 4.9. We have put the value as initial velocity is given as 4.9. and it is being vertically upward. Ball is thrown vertically upward. Hence, we are taking a negative sign. So it is 4.2 into 2 with a negative sign, half gt square. We have computed the value of g and t, and the calculation is concluded as 9.8 meters. U is taken as negative as it is upward because final velocity has to become 0. So U is going on decreasing. Using V is equal to U plus 80, V is equal to, and we have computed the values, and the value will become 14.7 meters per second. Now, in the next example, a rocket is fired vertically up from the ground with a resultant vertical acceleration of 10 meters per second square. The fuel is finished in 1 minute and it continues to move up. Even after finishing the fuel, it continues to move for 1 minute in the upward direction. So, what exactly we have to do? What is the maximum height reached, and after how much time from then will the maximum height be reached? The value of g must be taken as 10 meters per second square. So we are not taking as 9.8, rather we are taking an approximation, that is g is equal to 10 meters per second square. Now, in order to solve this question, the distance traveled by the rocket during burning interval, that is 1 minute, in which resultant acceleration is vertically upward and equals to 10 meter per second square will be. So height is calculated by equation ut plus half gt square, and it is found to be 18,000 meters by computing the values. The velocity acquired by it, velocity is estimated by function u plus gt. So we have computed the value, and the value comes to be 600 meters per second. After 1 minute, the rocket moves vertically up with initial velocity 600 meters per second and continues till height h2 till its velocity becomes 0, because final velocity has to be 0. So then we will use the equation, that is v square equal to u square minus 2gh, y taking a negative sign, that is g is negative, as g, and the value of g is 10 meters per second square. Now from equation number 1 and 3, we add the two heights, and that is 18,000 meters and 18,000 meters, that is 18 kilometers plus 18 kilometers, and that will become 36 kilometers. Now the B part of the question is the time to reach the maximum height after burning of fuel. So it is calculated by V is equal to U plus GT, but G must be taken as negative, being the rocket is projected up. So from this equation, we get the value of time, which is found to be 60 seconds. After finishing the fuel, the rocket goes up for 60 seconds. That is 1 minute.